Hi, my name is Chanchal Agrawal, and today I'm going to perform on gaze as input method for interaction. When I look at computers, I wonder how far we have come. In 1950s, a computer would be huge enough to occupy a room, even to do simple tasks like calculation. As we as we move forward, we went towards simple and more portable devices. For example, your laptop. Today, your laptop can perform things that would be considered as miracle in 1950s. It's amazing how far we have come in terms of compact hardware, effective software, aesthetic graphic user interface, and different methods of interaction. And that's what I'm interested in learning about. Currently, we have so many methods of interaction. We started with joystick, then we moved towards buttons and keyboards, mouse, touch, gestures, voice. Today, most commonly used methods of interaction would be mouse, keyboard, and the most dominating one is touch. Your laptop, desktop, smartwatch, tablet, all can be controlled by touch. One must ask that if we have so many ways of interaction, why do we need another one? Um, we measure a technology's success depending on how effectively it reduces manpower. The problem with all the previously mentioned interaction method is that they demand efforts from users end, like hand or leg or head movement. As we move towards ubiquitous computing era, we would want devices that reduces a user's effort as much as possible. It would be interesting to see a device which is completely hands-free. And that's where big companies are moving towards. Toby is a really huge company and a really good company. They focus on developing eye tracking devices and using gaze as an interaction method. Another similar company would be iMotion. Pupil Lab is also a company which develops eye tracking devices and softwares. Here are two examples by Tobii. One is a portable device, it's called Tobii Pro Glasses, and it's a mobile device so you can wear and move around. Tobii Pro is another example. However, it's a remote device. It is a beam-like structure which gets attached to your desktop or laptop to perform tasks like flipping videos on YouTube or increasing, decreasing volume or even play Fruit Ninja by by gaze as an input. The reason why eye tracking is so popular. Eye tracking not only provides as an input for interaction, it also gives us insight of user behavior, and that's a really huge contribution in terms of human computer interaction. When a user is shopping online, let's say a user looks at particular patterns or particular color or particular fashion style, so it would help companies to analyze users gaze and advise them in future similar products. In terms of content, when a user browses through content on internet, one can analyze what all data a user prefers to see, what all content they read, for how long they read, and this helps ads. It helps companies to give ads of such similar content or products. currently we use eye tracking devices for usability testing on analyzing how effective a product is. One can use eye tracking to perform, one can use eye tracking technique to analyze a user's behavior when they are going through some content online, like what all content does a user absorb, where did a user look at, and what all things a user missed out on. This helps a lot in terms of user interface design. You can arrange important data in more obvious ways, places where user would obviously look at. Eye tracking when eye tracking when merged with different technologies can be used in multiple ways. One of the good example would be if eye tracking can analyze a user's behavior, and if a system can analyze a user's cognitive load or attention span, then you can figure out underlying issues, especially like depressions, which is very difficult to figure out, right? And you can change the content, or you can change the UI design in a way that it generates a calm feeling. Now, gaze input as interaction has its own pros and cons. Eye tracking is convenient, like gaze input is convenient because it doesn't require a lot of efforts from users' end. It is quick because gaze input depends on saccadic movement, saccadic movement, which is the fastest movement produced by human body. However, when we consider a mobile device, a mobile eye tracking device, we would require cameras to perform eye tracking and processor to take it as input and give desired output. And this all thing would turn out to be a very bulky system, which a user might not even prefer to use. Eye tracking has very low accuracy. Though eye tracking is quick, which is good for us, however, the issue is that it's very difficult to track your gaze because it's fast and you don't want to select all the items that a user is looking at. Here are some graphs that I found from a paper I was referring to. So the author of the paper performs user case study on three different selection methods, that's mouse, touch, and gaze, and they figure out four variables. So throughput is how much processing does it take per second. In terms of mouse, touch, and gaze, gaze had the lowest throughput, which is a good thing. Gaze also turned out to be effective when selecting a target. As gaze is fast, movement time was faster when of gaze when compared to mouse and touch. However, the error rate in gaze was 4 times higher than mouse and touch. And that is one of the main reasons why we do not have gaze as an input for interaction methods. So, when you perform an eye tracking, you basically divide your eye movement in two categories. One is fixation and one is saccades. Fixation is a point where eyes would fix their attention on, like your gaze would fix its attention. And saccade is this fast movement which happens between two target points, two fixations. This theoretically seems easy to track, but there are way more issues than we can think of. When you consider fixations, you think your eyes would be stable, but your eyes are not. To absorb all the data, your eyes jitter around. It looks around for as much information as it can. And this jittery movement itself is one of the biggest reason why we have noisy gaze signal, which creates low accuracy. When when an eye tracking is performed, you need to know if a user has fixated its eye on a particular point, or if it's moving between two targets, or maybe the user got distracted from the screen, looked around, and came back to the same point as its previous focus. For these things, the system has to be smart enough to know a user's behavior, which is difficult to perform. And maybe that's the reason why why getting gaze as an input is difficult, because systems are not that smart enough that they can understand user precisely. So you cannot have currently, with all the technologies we have, gaze cannot be the independent input for interaction, but you can always pair it with different interactions that already exist. For example, eyes can move around the screen. Eye movement can help us get gaze input, which can perform the movement from one target to another. And to select, you can have tap or mouse click, or maybe blink or wink for selecting a target. And or you can come up with new gestures like tapping, or maybe zoom, or maybe, I don't know, wiggling of your hand. However, if we come up with a solution for gaze input, we can have way more application than one can imagine. The possibilities is endless. You can have applications in gaming industry which uses augmented and virtual reality to an extreme level. You can have a device, a smart glasses, or maybe mixed reality device which shows data in front of your eyes. The only point is to select it, and you can have gaze to move the cursor around, and tap or wink or blink for selection. For You can have another example like automated home appliances. If I give a system an instruction that if I look at coffee machine, and if I blink my right eye, the coffee machine should pour cup of coffee. And if I blink left eye, then it should pour me coffee with milk. It can have applications in educational sector. You can wear uh, you can wear an eye tracking device like a smart glasses and attend a meeting, and a processor maybe can do face recognition of all the people present in the meeting, so you can have name and background details of the person, so that you know whom to communicate with, whom you can relate more professionally. You can have your memories recorded, and the system can provide as a memory aid for people who has memory loss issues. There are way more applications than mentioned here, and we might we might have that within a decade or so. Here are here are papers that I have referred to present this presentation. Thank you for your time. Have a good day.